Hello everyone, this is Professor Roldan. This is Intermediate Algebra, section 10.2, exponents. So I want to go ahead and review a little bit of 10.1, some of the things that we saw in that section. Okay, so first of all, we saw negative exponents like x squared y to the negative 3. And you're not allowed to have negative exponents in your answer. So even though this looks like there's nothing you can do, basically what's wrong, or what we need to do about this expression, is to deal with that negative sign right there. And what that does is just you flip that base, whichever one has that. So it's basically going to be x squared stays on top and y to the third goes to the bottom. So we move it because it has a negative exponent, and after you move it to the proper place, it changes to positive. We also saw things like the product rule, where you add exponents. So let's say we had x squared y to the negative 3 times x y to the 5th. Okay, and here we would add exponents. So we have 2 plus this invisible 1. Okay, so that's going to be 3 x to the third power, and then the y is going to be negative 3 and plus 5. That is a positive 2. Okay, so basically just deal with it in one step. And then we had another version, which was something like this, and it's the quotient rule, because there's the quotient here, which is division. And so the shortcut of that was to subtract the exponents. Okay, so it'll be 4 minus 2 is 2, and y is going to be 4 minus 3 is 1. So I can leave it blank, or I can actually write the 1 there. Okay, so again, here we flip the y. Here we added exponents of the same base, and here we subtracted exponents of the same base. Okay, so that brings us to some more properties of exponents in 10.2, and that's called power to a power, and that's for any real number a and any integers m and n. We have a to the m raised to the n power. Sorry about that. That's going to be multiplication. That's the shortcut. Okay. So to raise a power to a power, we're going to multiply the exponents. Okay. So simply put, this is 3 times 4. Okay. So 2 to the third raised to the fourth power is basically 2 to the third, 2 to the third, 2 to the 2 to the third, 2 to the third. Basically 4 times. You're going to go ahead and just shortcut that and say, hey, 3 times 4 is 12, instead of adding all those up. And we're going to, and that's it. Okay. And over here it's going to be 8. And over here, negative 2 times 5 is negative 10. So again, you can't leave that, even though that's the right digit and the calculation is correct, you cannot leave your answer with a negative exponent. So we want to go ahead and flip this. And we don't have to do 3 to the 10th power. It's a pretty big number. This is fine, okay? Okay, so next one is product to powers. Okay, and this one is for any real numbers a and b and any integer n. So the product we're talking about is two different bases raised to the same power. Okay, you're basically going to apply this power to both of these, okay, through multiplication. So both of those have an invisible 1, so it's going to be a to the n and b to the n. Okay, so to raise a product to the nth power, raise each base to the nth power. Okay, so it doesn't matter if there's 3 bases, 4 bases, 10 bases, they're all going to get that power on the outside of the parentheses. Okay, so for this one, so when we talked about in 10.1, we saw the difference between this versus our example that we have here. Okay, so remember, this one means the x repeated 3 times, and this one means the 2x repeated 3 times through multiplication. Okay, so 2 times 2 times 2 is going to be 8, and then x to the third. All right, that's because we did that and that. Okay, next one, x to the fifth, y to the fifth. Okay, basically you're just applying this 5 to both of these. Okay, and same thing with the next one. It's going to be x to the negative 2 and y to the negative 2. They both are going to get that negative 2. Now you can't leave your answer like that, so we got to flip both. Okay. All right, the next one we have is the quotient, raising a quotient to powers. All right, so basically we have a quotient or division like this, 2 different bases, and it's raised to a power, the same power. And again, you're going to apply that power to all the bases inside. Doesn't matter how many there are. In this case, there's only 2 different bases, so they're both going to get the n power. Whoops. Okay. So to raise a quotient to the nth power, raise both the numerator, whatever it happens to be, and denominator, whatever it happens to be, to the nth power. Okay? All right, so let's take a look at what that looks like here. In the first example, we have 2/3 raised to the third power. So the numerator and the denominator both get that power of 3. And now we want to go ahead and simplify. So that's going to be 8 over 27. Okay, 3 times 3 times 3 is 27. Again, if you need help with your calculator, that's fine. So some people may have to type in 2 caret 3 equals, or enter, to get the 8. Or you may have to do instead of a caret symbol, you may have a symbol that looks like this, x to the y. So that's any base raised to any power you want. All right, and that way you can get bigger ones once we get there. Okay. Okay, the next one, they're both going to get this power of 2. And then we simplify the bottom, which is 25. Okay. And then the next one is just going to be both raised to the 4th power. And that's it. And then what about this one? There's a couple ways to do the next two. And that's okay. Standard version basically is applying both. So we're both going to get, they're both going to get the negative n. And then you have to flip both. So the b is going to go up and the a is going to go down. Because they both have negative exponents, which means they both need to move to the correct position so it can be positive. So b is going to be up here with a positive exponent. A is going to be down here with a positive exponent. Okay, and that's it. So the alternate way to do this is to go ahead and flip both. So I know they're both gonna be negative, so I go ahead and flip them. So it's gonna look like this. So that changes to a positive now n, positive n, and then go ahead and apply the power to both, and we get the same thing. Okay. So looking at this alternate method for the next one, I can say, well, I know this 3 is going to be up here, and I know the y is going to be down here, and I go ahead and squared, 3 squared is 9, and y squared is just y squared. Okay. So remember, this is a video, so you can pause it to write this stuff down. You can pause it before I do it to see how good or way off you are doing it. Hopefully you are pretty close to what I'm getting, or exactly the same. Okay. That's the great thing about videos. So that is the quotient rule, and we're going to go ahead and do some more problems that kind of mixes everything together that we just talked about. All right, so we're going to finish 10.2 with these examples that I have listed here. All right, so what you want to do is go ahead and try these on your own. Pause the video if you have to, and then see how you do. So I'm going to be doing 2 at a time. Okay, so letters A and B, just multiplying, and you should have gotten 2 to the 8th, and R squared, D squared. That's it. So why don't you go ahead and try the next 2 on your own and see how you do. All right, the answers to C and D. So everything all the bases in the parentheses get the power applied to it. So in this case, these are all going to be multiplications, raising a power to a power. So 2 times -2 is -4, 4 times -2 is 8, and both bases need to move to the bottom since they have negative exponents. And then D, you're just going to multiply, pretty straightforward. I do want to look at another example of C, because I saw some in the homework that were a little bit different. So let me change it up on you a little bit. So let's say if you had m to the negative 9, p to the 9, raised to the negative 8. Okay, so again, you're going to apply this negative 8 to both bases. So you're going to be multiplying both of those exponents. So the first one is going to be negative 9 times negative 8, which is positive 72. And the second one is going to be negative 72. So one's positive, one's negative. And then you need to go ahead and move the p down to the bottom. Now it's positive. Okay. And since they're different bases, we can't do anything else to this expression. All right, let's take a look at the last two. So E is just, you can do it either way that I showed you. I'm doing it the alternate method. I just flip it, and that way I have a positive exponent on the outside, and I go ahead and apply that power to all the bases inside. So 2 times 8 is 16, and then 2 raised to the 8th power. That's going to be just 2 to the 8th. Now the last one is not in your homework, but it is something you see in college algebra and other classes. So just go ahead and see if you can get that top number, the numerator, that top base into a base 7. Okay, see if you can figure that out, and I'll be with you in a minute. Okay, so we want to go ahead and see if we can get the top into a base 7, because if we have bases that are the same, we can do other things with it. So 49, really, 7 times 7 is 49. Okay, so we can actually change that 49 into a 7 squared. Okay, and that's what we're going to do here. So that 49 is now a 7 squared. It's the same thing. And now there's that 18 that's already there. And so if we apply our powers, our rules, we can do 2 times 18, which is 36. And now we have the same base 7. So we can go ahead and now say, hey, we have the same base. Why can't we just write this with only one base 7, and then subtract the exponents? It's just division, or the quotient of those two. So 36 minus 35 is basically 1, or just plain old 7. So that's the end of 10.2. And I hope you do well in your homework. Let me know if you have any questions. See you in the next video or in class. Bye-bye.